So hello students, welcome once again to our YouTube channel. So today we are going to solve here the last day second shift maths paper. Okay, so of course the questions are memory based questions still. Okay, so let's see how they turn out to be. See, if you remember, if the last day first shift paper was a bit on the more difficult side. Okay, we observed in our last session. Let's do it for this one. The last day, last session, last shift. The value of, the question is find the value of 6 over 3 raised to the power 26 plus 10 times 1 over 3 raised to the power 25 plus 10 times 2 over 3 raised to the power 24 plus dot 10 times 2 raised to the power 24 over 3 raised to the power 1. Now, barring the first term, this forms a GP. We all can easily see that. Okay, now what's the common ratio of GP? The common ratio of GP is of course 6, isn't that? So and how many terms we have? You start with 2 raised to the power 0 and you are going till 2 raised to the power 24. So from 0 to 24 we have 25 terms. So just apply it. So 6 over 3 raised to the power 26 plus 10 times. Now the first term is of course 1 over 3 raised to the power 25. A R, as we know, is 6 times number of terms minus 1 over 6 minus 1, which is 5. So that's it. So what do we get? Okay, yeah, we got it. So it is 6 over 3 raised to the power 26 and then plus 2 into 6. It can be of course written as 2 into 3. So 3 raised to the power 25 gets cancelled. So 2 raised to the power 26 minus 6 by 3 raised to the power 26. Isn't that bachon? It is 1 over 3 raised to the power 25. So multiply and divide by 3 to get it. So that's it. So that's the answer and that's an option also. So that was a simple question in that case, a direct question rather I will say. The sum of the coefficient. Now see, to start with, first question is definitely 100% doable. Okay, that's what we saw. Now coming to the second one. Look at this one also again. 1 plus x raised to the power 1000 plus x times 1 plus x raised to the power 999 plus x square times 1 plus x raised to the power 998 and so on till the last term, which is x raised to the power 1000. Now again look at this series. See, whatever the question be, which series is it? Isn't that a GP again? So that's a GP again. And what's the common ratio? Common ratio is x over 1 by x. So first term is 1 plus x raised to the power 1000. Common ratio x over 1 plus x raised to the power 1001. Isn't that? Because you are starting with x raised to the power 0 here. There is no x term, so I can write it as x raised to the power 0 and you are going till x raised to the power 1000. So again 1001 term minus 1 over x over 1 plus x minus 1. Now what does that give us? That gives us minus 1 here. So I can write it as taking 1 plus x after taking LCM denominator to the numerator. So we get it as 1 plus x raised to the power 1001. And 1 minus x raised to the power 1001 over 1 plus x raised to the power upon nothing. Upon nothing is left. X gets cancelled, minus 1 and we do okay. Now see, we need x raised to the power 499, x raised to the power 500. Now from where will we get it? Once we multiply it, so we get 1 plus x raised to the power 1001 minus simple x raised to the power 1000. So of course that's the binomial which will give us both the terms. So what are they? So 1001. See, for NCR, if we remember that, I believe a plus x, rather if I take for 1 plus x raised to the power n, coefficient of x raised to the power r is nothing but NCR. So it's simply 1001 C 499 plus 1001 C 500, and using the property of binomial coefficient which tells us NCR plus NCR plus 1 is n plus 1 CR plus 1. So it has to be 1002 C 500. So that should be the answer. Now again I will label it as a routine question. Okay, no trick. nothing new. It's a very routine question based on GP, a combination of GP and binomial expansion. So 1000 to C500 is the third option here. Now coming to this question, which says f of x, the function f of x is signum of sin x, cos x, tan x, cot x. Okay, so signum of four functions: sin, cos, tan and cot. Cot x. So these are four functions. Now how do we define signum function, bachon? We all know it, I believe. Signum of any function t or signum of t is 1 when t is greater than 0, it's 0 when t is equal to 0, and minus 1 when t is less than 0. T can be anything. T can be log function, t can be exponential function, it can be any expression, algebraic, even trigonometry. Now see, when are all positive? We have to simplify it. We have to, anything you want from here, you need to get rid of signum term. Okay, so for that we need to use this definition. Let's see. So then sum of the denotes where signum, okay, that's it. Then sum of the elements in the range of I. We have to get the range of the function f of x, what is whatever they are calling it as y. Okay. When are all positive? In first quadrant. So if x is in the first quadrant, all are positive. So the range is f of x is 4. Okay, now they can't be 0, all of them can't be, because when sine is 0, cot is undefined, cos is 0, tan is undefined. Okay, so that's not possible here. I mean t equal to 0, okay, that won't be the part of domain here. Okay, now let's go to the second quadrant. So let's do it quadrant wise. Let's see what do we get. Pi by 2 to pi. Now in second quadrant, sine is positive, so fx is 1. Rest 3 are negative. Isn't that? Cos is negative, yeah. So it is minus 2. Now in third quadrant, x belongs to pi to 3 pi by 2. In third quadrant, sine and cos are negative, so minus 1, plus 1, cot and tan are positive, so that's 0. In fourth quadrant, cos is positive, remaining 3 are negative. Okay, so in that case also we will get minus 2. So that's it. There is no fifth possibility. There is no fifth case. Okay, so that's it. So the range contains just 3 elements: minus 2, 0, 4. So the range, sum of the elements on the range is nothing but 2 here, bachon. Am I correct? Yeah, it's 2 here. Fine. So that's it. Now moving to the next one. Now see, this I will say a bit different question, though approach is simple. If you know signum function, they haven't defined signum function. See, that's a memory based paper. It may be possible that they would have defined signum function specifically in the question. If that's the case, then it's again a routine question. Okay, but otherwise I won't call it a routine question. I will say, okay, that's a bit different question. Now coming to this one, a is given to be 3 minus 4, 1 minus 1. We need a 100. A raised to the power 100 is 100 times matrix B plus identity matrix. Then we have to find sum of all the elements in B raised to the power 100. Okay, so to get a 100, I will go for a square. So what is it? So 9 minus 4, 5, minus 12 plus 8, minus 8, 3 minus 1 is 2, minus 4 plus 1 is minus 3. Okay, then if I get a cube, 3 minus 4, 1 minus 1. So what are we going to get? So a cube will be 15 minus 8 is 7, minus 20 plus 8 is minus 12, 6 minus 3 is 3, and minus 8 plus 3 is minus 5. I think we got the pattern. Okay, and what seems to be the pattern here? A, first element, a11 is 3, then square is 2, this is 7, so that's your AP, bachon. That's our AP. So 100 term of this AP. So what is it? It's 2k plus 1, so it's 201. Now minus 4, minus 8, minus 12, multiple of 4, so 100 term will be minus 400. 1, 2, 3, so it's going to be 100. And then minus 1, minus 3, so 2k minus 1, isn't that? So minus times 199, that's it. Now this is equal to 100b plus I. Now this is equal to 100 times b plus identity matrix 1 0 0 1. So if I bring it this side, so we get 100 times b. So 1 gets cancelled, it's 200, it's minus 400, it's 100, it's minus 200. Nice, great. So divide by 100, so therefore matrix B is nothing but 2 minus 4 1 and minus 2. If I'm not wrong, let's check it back. 2 minus 4 1 minus 2, that's our B. So now we have to get b raised to the power. So again, let's start. See, that's how normally, that's how I do. I won't say normally. If we are asked to get higher power of a matrix, I always start with a square a cube and try to get the pattern, the some sequence, a PG, PHP or some pattern, okay, which can help us in writing the general term for all the places, elements at all the places. That's what I do. So the same thing I'm going to try here. So 4 minus 4 is 0, great. Minus 8 plus 8 is 0, very good. 2 minus 2 is 0, okay, so that's, is it 0 minus, okay, yeah, nice. So b square is 0, so that means after square, for any power, it has to be 0. So b raised power 100, 200 to 500, whatever it is, answer has to be 0. So again, see, did I use any trick here? Answer is no. So again, that's a routine question. You don't have to think, you don't have to, there's no such big concept involved. Neither a trick is involved. Whatever they have given, whatever they have asked, use whatever they have given, try to get step by step whatever they have asked, the expression, you get the answer naturally, automatically. That's what happened in this question. So I call it a simple question in that case. Now this seems to be a bit better one. Better means a bit different one. So I can take 12 out. 3 plus greatest integer of x over 3 plus box of sin x, greatest integer of sin x, greatest integer of cos x dx. Okay, we have to evaluate it. See, minus pi by 2 to minus pi by 2 to 0, which is fourth quadrant. 0 to pi by 2 is first quadrant. In first quadrant both are positive. Both are positive means sin and cos both lie between 0 to 1, so their box will be 0. Minus pi by 2 to 0, sine is negative, cos is positive. Cos is positive, it has to be between 0 to 1, box is going to be 0. But sine is negative, and the range of sine on negative side is minus 1 to 0. So the box is minus 1. So I will break it into 2. 12 times minus pi by 2 to 0. 3 plus box x over 1. So what is it? This is negative 1, this is 0, so it's 2 dx. Okay, and then from 0 to pi by 2, both are 0, so it's 3 plus box x over 3. That's it. Now what? Pi by 2 is almost 1.57. Box greatest integer of x between minus 1.57 to minus 1. It has to be minus 2. Between minus 1 to 0, it has to be minus 1. Between 0 to 1, it will be 0. 1 to pi by 2, it will be again 1. Okay, so that's what are we going to get. So this is 6 times minus pi by 2 to minus 1, which is 3 minus 2, which is 1 dx. 1 minus 1 to 0, 3 minus 1 is 2 dx. And then it is 4 times 0 to 1, which is 4 dx, and then 4 times 1 to pi by 2, which is 3 dx, no? 0 to 1, yeah, 3 plus 3 dx, and that will be 4 dx. Then that's it. Now you all of us can solve it, and then you can match the answer, so I'm not going to do that. Next one is, a lift is going up to 10th floor. Number of ways in which 3 people can exit the lift at 3 different floors. 3 people at 3 different floors, okay? They can't get down from the lift on the same floor. No two can get down on the same floor. If the lift will not stop at first, second and third floor. So in that case, there is no sense of having 10 floors. That means our choice is from among the 7 floors. So 7C3. Which floor do you choose? Okay, so it's 7C3. Now, of course, 3 persons are there. 3 floors you have already chosen. So 3 balls, 3 person and 3 boxes, 3 floors. In how many ways you can put those balls in the boxes is 3 factorial. So answer is 7 into 6 into 5 by 3 factorial into 3 factorial, 42, 210. That should be the answer here, bacho. I think that was again a simple question. The maximum distance between the two curves. Okay, see, in the last video also we discussed about that complex number with the help of curve. Okay, we use circle. See, again that's a circle. It's a circle whose center is 2, 0 and radius is 4. Now which curve is it, bacho? Which curve is it? Doesn't it go with the definition that locus of a variable point, which happens to be z here, such that sum of its distance from two fixed points. Now mod of z minus z1 is always gives us distance between z and z1. So modulus stands for distance. So this is distance of z from 2, distance of z from minus 2. So 2 and minus 2 are two fixed points. Okay, so minus 2 and 2 is a constant, and that constant, which is 5 here, the sum of z from two fixed points is a constant, which is 5, which is more than the distance between those two fixed points, which happens to be 4. In that case it gives us an ellipse, okay, for which this is the length of major axis 2a. This is the length of major axis 2a. That's the ellipse. Now the first one is center 2 and radius 4. So 2, it will pass through this. Yeah. Now the maximum distance between the two, tell me what's the maximum distance? This is nothing but 5 by 2. See, isn't this the maximum distance? On ellipse take a point here, and on circle take a point here. That's it. So how much is this distance? This is 6 and this is 5 by 2. Bacho, so 5 by 2 plus 6, 12, 17 by 2, and that's it. That's it. The first option is the correct one. Very simple question. If you try to solve it using the geometry, the Argand plane, complex numbers on the Argand plane, bacho. Okay, I think we are done. All of you would have understood. Moving to the next one. Let f of x be this. Statement 1, fx is discontinuous at x is equal to 1. It is continuous at x is equal to minus 1. See, that's interesting. Limit as theta approaches 0 from the right side, positive. Okay, cos of pi x, so it is independent of theta, minus x square raised to the power 1 by theta. That's the purpose actually for giving it as 2 by theta, into sine of x minus 1. What does that mean? That means whatever x be positive or negative, okay, there won't be any problem as theta goes to 0. So 1 minus x square raised to the power 1 by theta into x minus 1. Great. Now see, as theta goes to 0 from the positive side, 1 by theta approaches infinity. Now with a given base to the power infinity, we have two choices. Depends on the base, isn't that? So if the base is greater than 1, then the value, it will approach to infinity. Base greater than 1 raised to the power infinity approaches infinity. But if the base is less than 1, and of course magnitude wise less than 1, between minus 1 to 1, then in that case, and it has to be positive, of course, that's why I said magnitude wise. In that case, if the power is infinity, it approaches 0. So it depends on x here. And one more thing, what if x is equal to 1? Why? Because if x gets 1, this is going 0. So let's get to the case. If x is equal to 1, so f of x, which is f of 1, how much is it, bacho? This is 0 because sine x minus 1 is 0. Now if 0, absolute 0 into anything is 0. So this is 0, this is 0, 1, and so cos pi it's minus 1. Fine. If x is greater than 1 and or x is less than minus 1, and because in both the cases x square is greater than 1, then it is infinity by infinity form. I think all of you will agree. This goes to infinity, this goes to infinity, and in that case, in infinity by infinity form, what do we do generally? We take the largest infinity common. There is only one infinity in both numerator and denominator. Take it common and then it gets subtracted. So in that case, it gives us limit theta approaches 0 plus cos pi x by x square raised to power 1 by theta minus sine of x minus 1 over, similarly 1 over x square raised to the power 1 by theta minus x minus 1. This goes to 0, this goes to 0 as theta approaches 0. So this is nothing but sine of x minus 1 by x minus 1 on the right side of 1 and on the left side of minus 1. Okay, so for these cases, now what if x lie between 1 and minus 1? In that case, since base, the magnitude wise base is less than 1, okay, this approaches 0, so this term is gone, we are left with only cos pi x. So in that case, fx is nothing but cos pi x. Now how many points are there? Okay, and this has to be in that case plus minus 1. Okay, in both the cases it is minus 1. How many points? We have two potential point where the function may get discontinuous. What are those? Minus 1 and plus 1. Okay, on the left side of minus 1, function is sine x minus 1 by x minus 1. On the right side of minus 1, function is cos pi x. So it is for sure that the function is discontinuous at minus 1. Okay, so the function is continuous at minus 1, discontinuous at 1. Let's see. So statement 1, 2 is false, 1 is correct. Let's go for 1 also. Isn't that, bacho? Yeah, because at minus 1 this is nothing but minus 1, but at minus 1, okay, this will give us some value, isn't that? It's like sine 2 by 2, which won't match. Now coming to 1, on the left side of 1, it is approaching value is minus 1. On the right side of 1, approaching value is 1, and at minus 1 it is minus 1, so it is discontinuous at both the points. So yeah, it's discontinuous at x is equal to 1, bacho. So statement 1 is correct and 2 is false, isn't that? Yeah, fine, yeah. Okay, so that's it. So fourth one is the correct one. Statement 1 is correct and statement 2 is false. Okay, I don't think there's any problem here. I was just thinking, is there any calculation error? I can't find it one, so that means that has to be correct. So let's move to, so that was a bit interesting, though it's not an absolutely new question. If any one of you or most of you would have practiced the question properly, well, okay, they would have definitely got such type of function which involve two variable within limits. Okay, so I mean that's not exactly a new question, but looking at the standard of JEE mains, it's a good question, I will say. Okay, so that's it. So now moving to the next one, the solution of this equation, which is x dy by dx is equal to y plus x square cot x, and y at x is equal to pi by 2 is pi by 2. Then we have to find some value, doesn't matter if we can solve it, and as we can see, we can definitely solve it. It's a simple LDE type of form, and that's it, bacho, that's it. Okay, LDE, where integrating factor is e raised to power integral of minus 1 by x, which happens to be 1 by x, and then multiply, we will get it. Okay, so I'm not going into its detail. Moving to the next question. Now statement 1 is that the expression 25 raised to the power 13 plus 20 raised to the power 13, 8 raised to power 13, 3 raised to power 13 is divisible by 7. Okay, see, observe that all the powers are odd. Okay, how can it help? I will write it as multiple 21 4 3, yeah, right, I think we got it 71, right? So I will write it as 21 plus 4 raised to the power 13, and 3 as 7 minus 4 raised to the power 13, 20 as 21 minus 1 raised to the power 13, and 8 as 7 plus 1 raised to the power 13. Now expand. Let's say we expand this. 21 is a multiple of 7. So all the terms except the last term, which will be 4 raised to the power 13, will be left out. All are divisible by 7, leaving remainder 0. So remainder you will get from here. Similarly here it will be minus 4 raised to power 13. Similarly here it will be minus 1 raised to power 13, and here it will be 1 raised to power 13. As I said, since all powers are odd, so they will appear with their corresponding sign. Ultimately everything will get cancelled. So this statement is true. That is, this expression is divisible by 7 for sure. Now the next is the value of the integral part. 7 plus 4 root 3 raised to power 25 is an odd number. Now that is interesting. See, they have mixed the things very properly, very well. I mean, they have used two totally different applications of binomial. One is to find remainder, and the one is, this is very typical question of binomial, okay, where we say find, of course this is a real number, so we call it, it has need to have some integral part and some fractional part. Let's say this is f1, fine. And then if we expand it, 7 raised to power 25 plus 25 c1, 7 raised to power 24 into 4 root 3, and so on, plus 25 c2, 7 raised to power 23, 4 root 3 square, and so on and so on. Okay, now what do we do is consider its conjugate in a way that it should be positive. Okay, though you can say, okay, conjugate has to be a p minus root q, of course, but we have to ensure that it remains positive. Okay, here so I mean, in that case it has to be, here is normally the usual thing, 49 minus 48. Interesting thing is, bachcho, 7 minus 4 root 3 into 7 plus 4 root 3 is equal to 1. Now, what doesn't that tell us that 7 minus root 3 is a fraction? It has to be greater than 0. That's what I said. That's why I always suggest that ensure that it is positive, and of course less than 1. So it's a fraction. I call it as f2. So as f2, open it, and then what I always say is add or subtract depending whichever gives us integer in RHS. Now tell me, by adding both the expression we get integer in RHS, or by subtracting? So of course here what, if we add, so you add them, I plus f1 plus f2 is 2 times whatever 7 raised to power 25, which is an integer. So that means this is an even integer. Right hand side is always even in that case. Bachcho, now the left side, so we have to get this integral part, isn't that? The integral part of this is an odd number. For that we need to check or get f1 plus f2. Now how? See, simple. That has to be an integer. All of you agree? Bachcho, that has to be an integer. By integer plus integer can only give us an integer. Okay, but f1 is a fraction between 0 to 1. It can't be 0. Why? Because that's not an integer. 7 plus 4 root 3 is not an integer. So similarly f2, of course this is f2, again this is not 0 and less than 1. You add them, f1 plus f2 greater than 0, less than 2. Only one integer is possible between 0 to 2, both hand open, and that is 1. So this is nothing but I plus 1 is equal to even, so I is odd. That's it. So both the statements are true. Not the correct there's nothing about explanation, so both are correct. So that's one interesting question. Moving to the next one, AB, a question of vector. Let vector AB is 3i cap plus j cap minus k cap, vector AC is i cap minus j cap plus 3k cap. Okay, APC, this is A, let's say for me this is origin, this is B, AB is 3i cap plus j cap minus k cap, AC is I cap minus j cap plus 3k cap. They are angle bisector. So angle bisector for the vectors, it has to be this, such that this is P and this length is given. What are we asked? This is root 5 by 2. We are asked to find area of triangle APB. This one. We have to find area of APB. AB we know. How much is it? I think it's root 11. 9 plus, yeah, root 11. AP we know. We need to know only this angle theta, and that's it. Okay, and that's your angle bisector. So we can easily do it. See, I will go for cos theta, cos 2 theta, angle between AB and AC. So what is it? So 3 minus 1 minus 3 is minus 1. Yeah, minus 1 by 11, right? Okay, so I need here sine theta, so I will write it as 1 minus 2 sine square theta. See, what I am trying to use is half AB means product of two sides and into sine of the angle included between those two sides. So half into root 5 by 2 into root 11 into sine of theta. Get sine theta from here, minus 1 by 11. So 2 sine square theta is 11, 12. So sine square theta is 6 by 11. So sine theta is nothing by root 6 by root 11. That's it, root 6 by root 11. So 1 by 2 into root 5 into by 2 into root 11 into root 6 by root 11. Okay, 4 root 30 by 4. Oh yeah, we have an option. Okay, fine. So root 30 by 4. So that's again a simple one. Okay, so a simple though, I mean not a difficult one. The function of f defined from R to R, fx is x over 1 plus mod x. Okay, see, at 0 the function is 0. For positive it is always positive. See, denominator is always positive, so the sign will be decided by numerator, and numerator you have x. As x goes to infinity, it will approach infinity 1. All of you agree? Why? For x positive, mod x will be replaced by x, and we have infinity by infinity form, but same degree polynomial in both numerator and denominator. In that case, the coefficient, the ratio of coefficient, leading coefficient in both numerator and denominator gives us the answer. I suppose you all know it. Okay, so that's it. On the right side, as x goes to minus infinity, of course this will be negative, 0, 0. And again, when see, for negative x you will replace mod x by minus x. In that case the ratio of coefficient is minus 1, so it is approaching this one. Now you may definitely say, how come we know that this is not going like this? Of course, for that we need to go for this is an odd function. Okay, so for one side, derivative. So of course, f dash x, when x is positive, x positive, so it is like 1 plus x whole square, and then in numerator, what do we get, bacho? Derivative of this 1 plus x minus x, which is 1 upon 1 plus x whole square. See, we got always positive, it can't be 0, so it's throughout positive thing. So that's it. Okay, so now it's an odd function, it will be throughout negative, I mean derivative, and decreasing increasing, in that case increasing is throughout increasing function. So we are done. So that's one for sure. Now moving to the next one statement, the function defined by x square plus 4x minus 30 upon this, and denominator can't be 0, it's a quadratic whose discriminant b square minus 4ac is negative. Okay, now see, it's for sure 1. Why? Again, as x goes to infinity, x square by x, okay, it goes to 1. As x goes to minus infinity, it again goes to 1, bachcho. Okay, so at infinity it is going, and it's always a continuous function. Why? Because that's what I checked, denominator can't be 0, so any combination of continuous function will be a continuous function. If denominator is not 0, it's a continuous function, and approaching on both the ends, infinity minus infinity is approaching 1. Okay, so that means it has to be a many-one function. So both the statements are true again here. So first first option is the correct one. Now moving to the next one. Now see, that's a very old question. I haven't done it, it's an extremely good question. I have done it, so it's a known question. In that case, what do we do? Summation. See, we go for, in such cases where we can't apply summation formula, we can't see any standard sequence like AP, GP, AGP, their combination, what do we do? Normally in that case, for me, if you ask me, in that case, every time I try to break or rewrite the general term of the series as the difference of two consecutive terms. If not consecutive, then there may be a gap of 1 or 2 terms, but difference of 2 terms. That's the one method I always rely on. The same thing we try here. So how? Add r square. See, you can say that I remember this question. As I said, it's a very common question. Okay, so summation in denominator, it's r square plus 1 whole square minus r square. So it's r square minus r plus 1 into r square plus r plus 1, and this is nothing but r here. Divide and multiply by 2. Now see what? I can write numerator as bachcho difference of these two, this minus this, okay, and when you divide it, so shall I, so r square plus r plus 1 minus r square minus r plus 1, and when you divide it, this and this gets cancelled, so you are left with r square minus r plus 1, divide it, the other one gets cancelled, and you are left with r square plus r plus 1. Okay, so that's what actually we try to get here, half times summation r goes from 1 to infinity, so 1 by r square minus r plus 1 minus, so difference of, now are they consecutive or not, so for that you need to check for the values of putting few values here for r, so put r as 1, so it is 1 minus 1 by 3, okay, plus put r 2, so 4 plus 5, see we got it, put r as 2, 4 5 7, see, that's it. One more, 3, you put 3, yeah, that's 7. So now you know whatever. Now what happens in such cases, if you are left with one term in the beginning, you are left with exactly one term in the last with opposite sign. So you are left with 1, so 1 with positive sign, we are getting it from here, with negative sign it has to be from here. How will you get it? By putting r as 25. So it is nothing but half times 1 minus 1 by 25 whole square, 625, 650, 651, and that's it. 651, whatever, I mean p by q form, we can simplify and do it, so that's it. Moving to the next question, the value of tan of, okay, yeah, 2, take it out, sine inverse 2 by root 13 minus cos inverse 3 by root 10 tan 2 theta, 2 tan theta. Okay, so in that case I will suggest you to write both of them in terms of tan and simplify it. So it will be tan inverse of 2 by 3, yeah, minus tan inverse of 1 by 3, bachcho, isn't that? Now apply tan inverse a minus b, tan inverse a minus tan inverse b, so 2 by 3 minus 1 by 3 upon 1 plus 2 by 9. Okay, so tan inverse of 3 by 11, isn't that? Now apply tan 2 theta formula, so 2 tan theta, so tan inverse gone, 1 minus tan square theta, tan inverse gone. So 121 is 112 into 11, 3 into 2 is 6, 112 is like 56, yeah, so we have 56 and in numerator we have 33, so that's the answer. Okay, so that's the answer. So again, see, that's one again question which I will call it a routine question, simple routine question, all of you can easily attempt it. Now that's an integral here, f of x, and see, all of you would have gone through such form where what we do is we go for substituting x with some algebraic term such that x is equal to t raised to the power LCM of the denominator of these powers. So 3 and 2 is 6. So how will it help? See, very simple. It will help by getting rid of these, irrational things. Okay. So 6 into t raised power 5, it will be t raised power 4 plus t raised power 3, taking t cube common, so t square and 1 plus t. We are done. All of us can easily solve it again, and then whatever they have asked doesn't matter, we can solve it. Now moving to the next question, image of a point 3, 2, 1 is q, and then distance of q from the line. Okay, see, now that's again a very regular routine type of question. The only thing is lot of calculation is involved, so I'm just discussing it. Of course I won't go for verifying the answers or option here. Image is something like this: alpha, beta, gamma. Now the line is passing through the point 1, 0, 1. DRs of the line are 1 to 1. Okay. Now how to find this image? See, this is M, which is midpoint of P and Q, and M is the foot of perpendicular drawn from P. So what we can do, we can use this equation of line the way we use it. How? By assuming a point on the line. Okay, so assume like equate all the ratio with p and get x, y, z in terms of p. So I can say let the point M be p plus 1 for x coordinate, y coordinate is 2p, z coordinate is again p plus 1. Okay, now get pm, drs, it's drs in terms of p. So p plus 1 is p minus 2, 2p minus 2 and then p. Now what? Pm is perpendicular to the line, so product of sum of product of drs should be 0. So a1 a2 p minus 2, b1 b2 plus 4p minus 4 plus c1 c2 p is equal to 0. Wow, p is 1. Great. P is 1. So we got m as 2, 2, 2. Nice. We got q. Alpha beta gamma. So alpha plus 3 by 2 is equal to 2, so this is 1, and likewise once you have alpha beta gamma, then you have to find distance. Now distance of any point, let's say q is whatever 1 comma anything. Now its distance, of course nothing is said, it has to be perpendicular distance. Now see what I will suggest, again 995 3 2 minus 2, so the point through which it passes 995 and drs are 3 2 minus 2. Okay, see, we have this length, distance formula, we have its drs, x2 minus x1, y2 minus y1, z2 minus z1, we have drs of the line, we have theta, and then this is nothing but aq sine theta. Bacho, that's it, simple. This is how we can easily simply get it. So again, as I said, I won't be going into its calculation. Let's move to the next one. In a triangle ABC such that A is at the origin, vertex B and the vertex B and C lie, okay, vertices on the parabola. So it's a horizontal open right parabola. Okay, so here we have A, let's say this is B, A is 2, isn't that? So 2t1 square 4t1, and let's say this is C, 2t2 square 4t2. Fine. Is the centroid. So centroid is given. Okay, that means we are given the relation. So what is it? So centroid is 2 common, t1 square plus t2 square by 3 is equal to 7 by 3. So we have t1 square plus t2 square is equal to 7 by 2, okay, and y coordinate is 4 common, t1 plus t2, so t1 plus t2 seems to be 1. So can't we solve it to get, let's see. Now what do we need? BC square. So what is the length here? BC square is x2 minus x1 whole square, 4 square, t2 square minus t1 square whole square, plus 16 t2 minus t1 whole square. Okay, so 4 common, and then t1 minus t2 square also common. This is t1 plus t2 whole square plus 4. We have t1 plus t2, so we are done. We need t1 minus t2, we are done. t1 plus t2 we directly have, t1 plus t2 whole square, this is 1, so this is 5 into 420. And then we need t1 minus t2 whole square, that we can easily find with the help of these two, isn't that, bacho? Is there any other method to get t1 t2 directly? Wait, or can we do it without getting t1 t2? Chaliye, anyways, squaring it, so t1 square plus, so this is 7 by 2 is equal to 1 plus 2 t1 t2. So from here we get t1 t2. t1 t2 is 1 minus 7 by 2 is minus 5 by 2 minus 5 by 4. Fine. So then we can solve it. Bacho, okay, put the value, we'll get it. So that's it. Simple question again. So here f of x is given to be 1 minus 2x plus 0 to x e raised power x into e raised power minus t f of t dt, and then we are given g of x, which is something something. For that we need f of t, we need f of t. So we need f of x. Okay, now that's a question I feel is a question of Leibniz rule of differentiation. How to differentiate? See, what I will be doing is we will be writing f dash x as -2, differentiating it. Acha, for that, since this is independent of t, so it's a constant with respect to t, I will take it out. Now we need to apply product rule. This is one function and this integral is another function. So applying product rule, so e raised power x derivative and then this as it is plus e raised power x as it is, then derivative. Now how do we differentiate it? We replace the upper limit in place of t in the function, in the integrand, and then derivative of upper limit. So it is e raised power minus x into f of x, derivative of x is 1, minus lower limit, and then derivative of lower limit. Lower limit is a constant, derivative is 0, we don't need to write it. So that's it. So that's your f of x. Okay, so f dash x is equal to -2 plus, okay, see, we can replace it from here. This is the entire thing we have here. So it is plus fx -1 plus 2x plus f of x, and that's it. So dy by dx, we came across something like our linear differential equation, isn't that? Dy by dx minus 2y is equal to 2x minus 3. Differentiate, bachcho. Sorry, integrating. LD, simple LD, we can easily integrate and get the answer. Okay, so I am leaving it then, because see, once we get fx, okay, what do we expect here? E raised power -2. We need to check, I mean, karna padega. We need to solve it. So just solve it and check it. Okay, and then again you have to apply Leibniz rule here. I think we will get it. Okay, I'm pretty sure we'll definitely get it. Okay, so applying g dash x, local maxima, local minima at p and q, g dash x is equal to 0. So once you put x here, so it will get some factor type of thing, and then not x, f of x here. Okay, and then we will get it, right? Next is, if the arithmetic mean of 1 by a and 1 by b is 5 by 16, so that means 1 by a plus 1 by b by 2, so it's 5 by 8. And a4 alpha b are decreasing ap, okay? A4, a plus d, alpha, a plus 2d, b, a plus 3d. So let us not forget that this is 4, this is alpha, this is b. So we have two deletion. One is this, a plus d is 4, and the one is this. So I will just simply move ahead the simple algebraic method. If anyone else has anything in his or her mind, can discuss it here. So taking LCM, okay, so 2a plus 3d. So 2a plus 3d over a into a plus 3d is equal to 5 by 8 here, bachcho. Okay, now putting the value, so 2 common, a plus d is 4 plus d, a plus d 2d, a is 4 minus d, and this is 4 plus 2d, 4 plus 2d is 5 by 8. Now you solve it. A quadratic in d, cross multiply, whatever, you solve it. See, it's an increasing AP, remember this. So that means D has to be positive. So most likely we'll get, of course it's a quadratic, most likely we will get one positive, one negative D. Okay, so positive D will help us, and once you have the value of D, you have everything here. And then you have to check in which interval does the roots of this equation lie. How can you check it? Shall I do it in that case? Wait, let me try quickly. 64 plus 8D is equal to 4, 4, 16, 80 minus 2d square minus 10d square, then minus 4d, 8d plus 4d plus 20d. Okay, so it is 10d square minus 12d minus 16 equal to 0. So 5d square minus 6d minus 8 equal to 0. Done. 5, 8, 40, 10, 4, 40. So d is 2. D is 2, A is 2. So our quadratic in that case is alpha. Alpha is, where is it? A plus 2D, 6x square minus 2x plus 2 times alpha, 6 minus 2b, 8, 16, 10 minus 20 equal to 0. So 3x square minus x minus 10 equal to 0. See, roots have to be of opposite sign. Why? Constant is negative. Open upward quadratic, constant is negative, so roots have to be of opposite sign. So either the answer can be this or this. Now what we have to check? See, for roots to lie, for open upward quadratic, if it is given for roots to lie between two numbers x1 and x2, okay, and it contains 0, okay, so then it's for sure that at x1 and x2 both these points the value of the quadratic has to be positive. That's what you need to check. So at -1, if I put -1, it's negative, so it's not true. So the only option left is -2, 3, and that has to be the answer here, bachcho. So now moving to the next one, and next question is, if the ellipse is this, okay, it's a vertical ellipse, and hyperbola is this, it's a vertical hyperbola having same foci. See, it's a simple question. We have already done it in the first session. I mean shift 1 case. I'm leaving it, bachcho, in that case, having same foci. So you have foci here, you match it with the foci, you get lambda, okay, and then latus rectum, everything is known. I'm skipping it. It's a very routine question, we all can easily do it. Moving to the next one, a circle x square plus y square intersect the x axis at -2 and 0. And 0. If two variable points alpha is equal to beta plus pi by 2, okay, so if I consider beta here, q, then rotate it by 90 degree, it has to be p. Then find locus of point of intersection of AP and BQ. AP, BQ. We have to find this thing. We have to find the locus of this point as P and Q move on the circle. We have to get rid of alpha and beta. Okay, see. This angle is 90. This is beta, and this entire thing is alpha, isn't that? Beta plus pi by 2. So this is nothing but 180 minus alpha. Okay. Now this is R, this is R. So isosceles triangle, beta gone. So this is 90 minus beta by 2. So this is 90. This is 90 plus beta by 2. Similarly, 180 minus alpha, so this is alpha by 2, alpha by 2, so this is 180 minus alpha by 2. Now that's a OQRP is a quadrilateral, 90, 180, 90, 180, 360. So this is nothing but alpha by 2 minus beta by 2. Sum is 360, okay. And this is nothing but pi by 4. I think from here we will get it, and I think we got it. So it's like there's a point A, x comma y, where angle is pi by 4, and the point -2 comma 0 and 2 comma 0 subtend an angle pi by 4. So it has to be on the circle. It has to be on the circle, isn't that? Okay, so at center it need to subtend pi by 2 angle. So can we go for applying rotation form for complex number? Okay, if I assume this point C to be again z0, z, so rotate this anti-clockwise direction to get this. So rotate, so z plus 2 to get z minus 2 by an angle of, so both the modulus distances radius has to be same, isn't that? See, I think you people got it what I am doing. If a fixed line segment subtend a fixed angle, okay, at a point, that point has to move on a circle, for which the line segment has to be a chord. Okay, so if the angle at circle, so if the angle at any point on the circle is pi by 4, then in that case at center it has to be pi by 2. If it is center, it has to be radius. So this is same, e raised power iota pi by 2 cos pi by 2 and that's iota sin pi by 2, and that's it. So what is z here? So z minus 2 is equal to iota z plus 2 iota. So z is 1 minus iota, this is 1 minus iota, 2 times 1 plus iota. So z is 2 times, simplify it, so 1 plus iota square gone, 2 iota upon 2, so it's 2 iota. So center is 2 here, 0 comma 2, so center is 0 comma 2, and then we have radius also, isn't that? So 2 0 0 2, so radius is 2 root 2. So it's a circle, x square plus y minus 2 whole square is equal to 8. That's it. The point is, can we have it on the other side also? I don't think we can't have on the other side. Why? Because they are given alpha has to be greater than beta. In that case, if alpha is greater than beta, if we put it on the other side, let's say here in that case it has to be beta, let's say this is some angle beta and then you add 90 by 2, this is alpha. So in that case AP and BQ, the point will always intersect within the circle. Here it will always intersect outside the circle, but then also it can be the case within the circle, can also be the case. Okay, within the circle won't be the case, no? In that case, how can this be pi by 4? Within the circle, angle has to be more than pi by 4. Yeah, that will be the problem, bachcho. By angle has to be, this angle is pi by 4. In that case, angle has to be more than pi by 4, because this is diameter, it subtends 90 degree at any point on the circumference. If the point is inside the circle, it has to be more than that. Okay, so that's not possible. So let's check it out. Center 2, radius 2 root 2. Yeah, I think this one. A is the correct answer. Bachcho, first one is the correct answer, so we are done. Now the next one is, consider two parabolas, y is equal to 4x square, so it's an open upward vertical parabola. Y is equal to x square plus 27, it's again an open upward, shifted by 27 unit. Rather it will be something like this. Okay, why so? Because see, it is 4 times, so it will be more steeper. The first one will be steeper. Okay, so at any point of time, it definitely after some time it will definitely intersect it. So the second one has to be a bit broad, right? And line is y is equal to alpha x. Okay, if the area bounded by P1 and P2 is 6 times the area bounded by P1 and L, P1 and P2 and P1 and L. Oh, we can get it. We need to get just these points. So y square is equal to x square, 3x square is equal to 27. So the points are minus 3 comma whatever. X is 3, we don't need it, 3 comma something. Okay, 36 and whatever. So minus 3 to 3, we got it. Now area between P1 and the line, that's it. This is just 6 times, so we can just simply compare it, because line is always above the parabola till its point of intersection, after 0 comma 0 and the point of intersection. So you can easily do it. I am not going into it, so we can find it out. Next is, let L be the distance of the point from the line. Point is P which is -1, 2, 5 from the line measured parallel to the line having direction. Oh, got it. See, it's like that's a road, that's your location. Now you have to reach the road. It's not like that you always have a path which is perpendicular to the road. No, it is possible that the path which is available to reach this road is in this direction. So of course in that case you need to measure the distance along this direction. Someone asks you how much you have to travel to reach this road. That's the case here. Okay, so you have to travel along some direction to reach this road, and then we need this distance, and that's a simple thing. How come? Because we know how to write this equation. Point is given x1 y1 given to x plus x1 x minus x1 upon a, direction is 4, I mean dr, y minus y1 upon b, z minus z1 over c, that's the line, and this is a given line. This is the point of intersection. Get the point of intersection, use distance formula, and we have it. Okay, so I think we all can complete it, and that's it. So we are done. So that was the second shift. I will say the last day first shift was comparatively tougher than the last day last shift. Okay, this was comparatively easier than the previous one. Now we will go back to 24th, the second last day, shift 1 and shift 2 in our next session.